This is a mini lecture on the Intro to Organic lesson, lesson 8. And I know you know some organic nomenclature already, but I'm going to show you some new things. But just to remind you about how to name a simple compound. You find, so this simple one, we're going to find the longest chain. Then we're going to identify our branches, so that's a branch. Then we're going to number our chain from the end closer to a branch. So this end will get 1, 2. Okay, and then when we go to name it, we start with the branch. And this branch is 1 carbon big, so it's a methyl. And so when we name it, we'll start with that. We have to give its location is 2. Then the branch type is methyl. And then the last name is 4 carbons, so it's butane. If you have any trouble at all with the organic nomenclature of alkanes, I really strongly suggest you look at the videos from lab last week again. They go by it step by step, and sometimes people start to get it toward at the end. And if they go back and listen to the beginning ones, it really helps them. Today we are going to look at some of the structures that are written as lines instead of with the carbons shown. So you're probably going to have to pause me to get this written down before I start going through it. When they're written as lines, you just have to identify where the carbon atoms are. And you do that by, I like to mark them. It makes it a little easier to see. So at every bend and every end, it's like a bend and an end, in this intersection as well, there's a carbon atom. So those are all my carbon atoms that I'm marking in blue. It really does help to mark them so you don't overlook them. And then again, I'm going to find my longest chain, and I can see that if I go just straight across, essentially like that, I get, how many do I get? 4, is it 8? Or if I go up and use this, I also get 8, so it doesn't matter. I'm just going to choose this way, which makes this a branch and this a branch. This branch up here has 2 carbons, so it's an ethyl branch. This branch down here has 1, so it's a methyl branch. My longest chain, I need to number it, and I'm going to number from the end closer to a branch, so I'll number from this end. Okay, and now I'm ready to put together the name. I start with my branches, and which one do I talk about first, the ethyl or the methyl? I have to go alphabetically first, so I'm going to say the location of the ethyl is 3 ethyl, and then a dash, and then the methyl. Okay, and then the last name is the longest chain, so it's octane. Okay, and I want to show you something about the format here, because this next week you're going to be entering these names into your computer, and it's very important that you enter them exactly right. And I'm not this picky like on a written test, because it's really hard to tell like where there's a space, but you need to know there are no spaces in this whole thing. So when you enter it on the computer, don't put any spaces. And then a dash goes between a number and letter. and a comma goes between two numbers. Okay, and we don't have any commas in this one. That would be like if you had 3,3 di ethyl or whatever. So let's see, what else do I need to tell you? So we alphabetize by the first part. Okay, well, I guess that's it on this one. Okay, so we're going to find our longest chain. Oh, let's mark the carbons. So now the longest chain is, there's only one that has 7. 1, 2, 3, 4, 5, 6, 7. So we'll do this. Okay, that makes that a branch. This is a 2-carbon branch. So this is a methyl branch, this is an ethyl branch, and this is another methyl branch. Then I'm going to number my chain from the end closer to a branch. And if I check, I've got 1, 2 from this end and 2 from that end. And actually both ways the ethyl is on the third one. So this is going to be the same no matter what. So it doesn't, and they're both methyls, so I don't have to worry about alphabetically first. So I'll just start numbering from down here. Okay, and now I'm ready to put together my name. I'm going to start with, which branch do we start with? We start with the alphabetically first, so I'll start with the ethyl. I'll say 4 ethyl dash, and then I've got 2 methyls, and they're 3 on 3 and 5, 3 comma 5, no spaces there, dash, di, methyl, and the last name with 7 carbons is heptane. Okay. Pause me if you need to. Okay, on these, these two are kind of similar. Let's mark their carbon atoms. And on these, they don't have any branches, but they do have a double bond. And so when you have a double bond, you have to number the bonds, and you number from the end closer to the end. So this is bond 2, and this is bond 2. Okay, and then, so to name them, I would say this is 2, get a different color, 2, what was it, 5, ene, because it has a double bond, it's not ane, it's ene. And this one as well is 2 pentene. Okay, and the thing is, they're not really the same. When I draw them like this, you need to be able to see if they're cis or trans. And the way that I kind of think about it is that I imagine that the double bond is like a river. So if it's like a river, I can kind of draw a parallel. And then I see that both of the carbon groups are on the same side. So same, we go with cis. Cis means same. We put that in the front. On the other one, when we draw our river, like that, and the carbon groups are on the opposite sides or across from each other, and so that is called trans. Okay. Okay, get rid of that. And then, are these isomers or are they conformers? Are they the same compound? Well, we know they're not the same compound because they have different names. And so they are isomers. We could check and see, do they have all the same number of carbons? Let's figure that out, or hydrogens. Because to be isomers, they really have to have the same number of hydrogens. And so I could figure this out here. I'm not going to write all the H's, I'm just going to write little lines. There's 3. Notice that here, let me get rid of this 1, it makes it confusing. Here, this carbon has 3 bonds already shown, so I'm just adding 1 hydrogen there. Same with this one, we count the double as 2 bonds, so 3 bonds, so it needs 1. We need to make sure carbon has 4 bonds. I'm going to do 2 there and 3 there. So this compound is C5H10. Then if I do the same thing on this one, I get the same formula, C5H10. So yes, these are definitely isomers. They have the same molecular formula, that's this, and different structural formulas. They look different like that. Okay, so if I had done this, if I had counted the hydrogens and this one had different number of hydrogens, then they would be unrelated compounds. They would not be the same. They would not be isomers and they would not be the same compound. They would be neither of those. Okay, let's look at these. Okay, so my question is, what about this? Is it an isomer or the same compound or neither of this one? Well, the thing is, when people see this, they think, oh, that has nothing to do with the trans-2-pentene. It doesn't look like it. So let's just look. Let's mark their carbons. 5 carbon atoms. And then the hydrogens. So on this, it has 2 bonds already. So I'm just marking hydrogens on it. So I come up with it's C5H10. So because it's C5H10 again, it's a different structure, same atoms, this is an isomer. And by the way, what would we name this? It's a pentane. It doesn't have any double bonds, but to say that it's in a ring, we say cyclo. And no space there, but okay. And this one, I did this one just to kind of show the other way of writing this. This has, the chain is kind of like this. That's the carbon chain. And so the double bond is on the second one, so I'll put it there. And so this is another 2-pentene. And is it cis or trans? So to decide, I go through the double bond like it's a river. It's extended out. And these are on the opposite sides. The carbon groups are on the opposite sides, so this is trans. So this, since I came up with the same name, these are really the same compound. Just drawn different ways. We might say they're conformers. Okay, the last thing I want to show you, these questions there's some of them on your handout for practice too. This is how your lesson quiz will be online, the one where you get 8 questions and you have to get 7 right for 100% and you can get bonus. So I wanted to show you how they are because they're kind of different. So what it is I'm giving you a name, but it's not the correct name. It's not the official IUPAC name. But it's okay because I can draw this structure. It implies a structure. So what I'm going to do first is draw the implied structure. I'll start with the last name, and I'm just going to draw the carbons. So propane is 3 carbons, and then I'll just kind of pretend that it's numbered this way just to make it easy. And on the second carbon, I'm going to put an ethyl. And on the third carbon, I'm going to put a methyl. Okay, so after I draw the structure that's implied, I'm going to name it. I'm going to think about how it should be named. And most of the time, you're going to look at it and find the longest chain again. A lot of times when this structure was named, maybe the longest chain wasn't really found. So I'm going to reconsider this. So I'm going to get rid of these numbers. And I see the longest chain is actually like that, isn't it? Which makes that a branch. So I've got a methyl. And then I just name it. 1, 2, 3, 1, 2, 3. It's gonna, I can number it either way. I'll get the same name. And so I get 3 methyl pentane. Now this is the part when you're doing this on the test or on the online quiz, no spaces in the whole thing. No space there, no space on any of this. Okay, let's try another one. So I just draw what it says, butane, that's 4 carbons. And this one has an ethyl on the 4th carbon, so that would be here. And then I re-look at that, I take a fresh look and say, oh, well there's the longest chain. And so that is, it's 6, so that is just hexane. And it can be that simple. Okay, well that should be all you need to know to do your team exercise handout.